Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. Today we are going to learn the proof of division of complex numbers in their polar form or in their circular form. If this is your first time, kindly subscribe, share, like and comment for more interesting updates and video regarding this topic. For when you have a complex number z in the polar form, you have the modulus, which is r multiplying cos theta plus I sin theta. Okay, this is it. So let's consider complex number 1. Okay, so this is one complex number, which is z1. So this will also be what? r1, and this theta will be what? Theta 1. This angle will also be theta 1. So the second complex number will be z2, which is equal to r2 multiplying cos theta 2 plus I sin theta 2. If that is so, the quotient of these two complex numbers becomes, you have z1 over z2. Remember, quotient has to do with what? Division, which is equal to, we'll also divide r1 over r2. Then, this becomes, we have cos, so let's do it this way. We have cos, but we have theta 1, then minus theta 2, this way. Then plus I, then you have sin theta 1 minus theta 2. We've done for, I think, the multiplication of complex numbers in their polar form. This is the division. So if you are new here, kindly visit my previous lectures on the multiplication. Okay, everything is well proved, well understanding. Okay, so let's look at the proof. Why are we saying this? So if that is the case, let's see. We have z1 over z2, right, which is equal to r1 over r2. So I will divide z1, which is equal to this, over z2, which is equal to that. So I have z1 over z2, which is equal to r1 over r2. Then I have cos theta 1, then plus I sin theta 1, all over cos theta 2 plus I sin theta 2. Now, for this, in complex numbers, whenever you have a fraction, okay, what you do is you have two complex numbers divided. What you do is to look out for the denominator of the complex number. Then you multiply the conjugate of the denominator of the complex number. Do you get that? So you multiply, so you find the conjugate of this, then you multiply the numerator by the conjugate of the denominator, then you multiply the denominator by its conjugate. Again, if this is your first time, kindly visit Introduction to Complex Numbers. Everything is well explained. Addition of complex numbers is well explained. Subtraction of complex numbers is well explained. Multiplication of complex numbers is well explained, as well as division of complex numbers. So the conjugate of this is minus. Okay, so we have a plus ib. This is the real number part of the complex number. This is the imaginary part of the complex number. So the conjugate of this is a minus I what? B. You get that? So we just what? Reverse the sign or the polarity. If it is positive, it goes with what? minus or subtraction, and vice versa. As a result of that, I'll multiply the denominator, okay, this by its conjugate, which will become what? We have cos theta 2 instead of plus, do it what? Minus, because it's conjugate, minus I sin theta 2. Then over, we just repeat this over here, okay? So we have cos theta 2 minus I sin theta 2 in that regard. So what we'll do is to multiply this by that, then this by that. For the denominator, you can simply use difference of what? Of squares, okay? But let's go step by step. So I have z1 over z2, which is equal to r1 over r2. Then I have cos theta 1. I pick this term, then I open bracket. Everything over here will be, so it's just a matter of doing copy and paste, okay? So I have cos theta 2 minus I sin theta 2. I'm down for the first term, then I pick the second term, which is what? Plus I sin theta 1. Then I have cos theta 2 minus I sin theta 2. Then all over, I have cos theta 2 this way. This also multiplies what? Everything here, okay? So I have cos theta 2 then minus I sin theta 2. Then I have plus I sin theta 2, which will also multiply this expression. I have cos theta 2 minus I sin theta 2. Very, very simple, step by step. So I have z1 over z2, which is equal to r1 over r2. So I have cos theta 1 by this gives cos theta 1 multiplying what? Cos theta 2. Then minus, multiply this by this. I will have I sin theta 2, then I have cos theta 1. Then here I have plus this by this gives I sin theta 1 cos theta 2. Then positive and negative, when they commute, we have negative. So minus I times I gives I squared. So minus we have I squared. Then we have sin theta 1. Then we have sin theta 2. This way. Then all over this by this, we have cos theta 2, cos theta 2. This by this, we have minus I sin theta 2. Then we have cos theta 2. Then plus this by this, I have I sin theta 2. And I have cos theta 2. Negative and positive, okay? We have negative. I times I squared. I have I squared. Then I have sin theta 2 sin theta 2. Okay, so now we have this to be equal to, we have z1 over z2, which is equal to r1 over r2. Then we have cos theta 1, cos theta 2, minus I sin theta 2, cos theta 1. Then plus I sin theta 1 cos theta 2 minus I squared is the same as what? Negative 1. Then I have sin theta 1 sin theta 2. Then all over I have this cos theta 2 cos theta 2 minus I sin theta 2 cos theta 2, then plus I sin theta 2, we have cos theta 2, then minus I squared is the same as what? Negative 1. So I have negative 1, then I have sin theta 2, then sin theta 2. So viewers, for want of space, let's move on to this side. So viewers, this expression, okay, this is the same as that. Okay, I did that because of space, alright? Now, to make things very simple for us, negative multiplying negative gives what? Positive, alright? So I can just do this and simply write what? Positive, okay? Then negative and negative also, here when they commute, you get what? Positive, okay? Negative by negative gives what? Positive, okay? So let's proceed. So I have z1 over z2 is equal to r1 over r2 this way. Then we have cos theta 1 cos theta 2. Then minus I sin theta 2 cos theta 1. Then we have plus I sin theta 1 cos theta 2. Then plus sin theta 1 sin theta 2 all over cos theta 2 times cos theta 2 gives what? Cos square theta 2 from trigonometry, okay? I have I, then minus I sin theta 2 cos theta 2 plus I sin theta 2, I have cos theta 2, then plus sin theta 2 by sin theta 2 is sin square theta 2 this way. Okay. Okay, so we have this. So let's rearrange. Okay, so by rearrangement, we have z1 over z2, which is equal to r1 over r2. Then we have this cos theta 1 cos theta 2 over here. Then we pick this because we want to rearrange them. Then plus sin theta 1 sin theta 2. So we are done with this and that. So we will now join this, okay? So I have plus I sin theta 1 cos theta 2, then minus I sin theta 2 cos theta 1. Okay, or you can decide to bring this here and this over there. It's still the same. Then over this cancels that, okay? This cancels that. So we have this cancels that because it goes to 0, alright? So we have cos squared theta 2, then plus sin squared theta 2. So I have z1 over z2, which is equal to r1 over r2. Then I have this. We have cos theta 1, cos theta 2. Then we have plus sin theta 1, sin theta 2. Then plus, we have I here, so we'll factorize I out. So you have I, then you have sin theta 1, then we have cos theta 2. Then we have minus here, because negative times positive times negative gives negative. Then we have sin theta 2, then we have cos theta 1 this way, all over cos squared theta 2 plus sin squared theta 2. Viewers, in trigonometry, we know that when we have cos, so note, when we have cos of, we have A plus B, okay? This is the same as cos A, cos B. For cos, positive goes with negative, okay? So if this positive, then this goes with negative, then we have sin A, sin B. If that is so, then I can say that cos A minus B is the same as, then negative goes with positive. I have cos A cos B plus sin A sin B. Again, for sin they have A plus B. This is the same as we have. So for sin, we have sin A plus B. So for the sin, we have sin A cos B. We have plus either cos A or sin B cos A. So for the sin, you have sin A here, over here, sin B. You have cos B here, cos A. If that is so, then I can also say that sin, then A minus B is the same as what? Sin A cos B minus sin B, then cos A. But when we're dealing with the proof, realize that here we use theta 1 and theta 2, okay? So I can say that instead of me saying A, I can say A is the same as what? Theta what? Theta 1. And B the same as what? Theta 2. So we have theta 1, and I have theta 2. Do you get it that way? A here, the same as theta 1. This is theta 2. This is theta 2. This is theta 1. As a result of that, I can say this is theta 1, theta 2, then theta 1, theta 2. We have theta 1, theta 2. Then we have theta 1, theta 2, step by step. I have theta 1, theta 2. This is theta 2, theta 1. Then we have theta 1, theta 2. We have theta 2, theta 1. You did this way, you won't be what? Confused. Okay, so let's do substitution over here. Lastly, remember that we have cos squared theta 2 added to sin squared theta 2. This identity trigonometry, this is what we call the Pythagorean identity. It will always give you what? 1. So this is the same as sin squared theta 2 added to cos squared theta 2 is the same as what? 1. Okay, so having done this, let's see what we can do over here. So I have z1 over z2, which is equal to r1 over r2. This side, we have cos theta 1, cos theta 2, plus sin theta 1, sin theta 2. Let's see. We have here cos theta 1, cos theta 2, plus sin theta 1, sin theta 2. This is the same as that. Is that not so? So I can simply equate this to this because they are the same. Okay. So instead of me writing the whole of this expression, I can simply what? Write this because this is the same as that. Do you get it that way? So instead of me writing the whole of this, I'll write what? Cos. Then I have theta 1 minus theta 2. Do you get it that way? Then you have plus over here. Then plus I. Okay, so for this side, sin theta 1 cos theta 2 minus sin theta 2 cos theta 1. Let's see. Here we have sin theta 1 cos theta 2 minus sin theta 2 cos theta 1. This whole expression is the same as that. Do you get it that way? So me writing the whole of this will be complicating. So I can just write this instead of that because they are what? They are the same. So I have plus I. The whole of this is the same as this. I have sine. So I have sine what? I have theta 1 minus theta what? Theta 2. Do you get it that way? Now all over cos squared theta 2 plus sin squared theta 2 is the same as what? The same as 1. This way. So finally, I can say that complex number z1 over z2, which is the same as r1 over r2, is the same as cos. Then you subtract the reference angle or the argument. This angle is what we call the reference angle or the argument. So I have theta 1 minus what? Minus theta 2. Then plus I, then sine. You again what? Subtract their argument or reference angle, which is theta 1 minus theta 2. This way. That's it. Viewers, this is the proof. This is the reason why whenever you divide complex number 1 over complex number 2, this is the expression you are supposed to get. So we have, you divide the modulus of that complex number 1 over the modulus of the other complex number. Then you take cos of the angle. You subtract one angle from the other. Okay. Yeah. So this theta 1 is coming from the complex number 1. Theta 2 is coming from the complex number 2. in that regard. Viewers, this is the end of the tutorials. So far as this YouTube channel is concerned, you are going to learn a lot. Stay safe, stay blessed.